Sammons, and today I'm going to be telling you about my research project, which focuses on fungi's effects against Varroa mites. And so you all probably already know a good bit about Varroa mites, but I figured I would still do a brief background on them. So Varroa mites cause colony collapse disorder, which is where all the worker bees just leave the hive and the hive is basically killed. And then Varroa mites also cause deformed wing virus, which is where the honeybees have deformed wings. And so the way Varroa mites spread to different hives is by hitchhiking on either robbing bees, drifting bees, swarming bees, or absconding bees. And absconding bees are when all bees leave the hive, even the queen. And you probably all are well aware of that the beekeepers, one of their top goals is to minimize the level of Varroa mites in their colonies. That way the colonies can survive the colder months and they'll be strong hives in the springtime. So the whole reason I even wanted to do my research project was because the current treatments against Varroa mites, which are oils and chemicals, have some issues with them. So oils just are not very effective from the start, and chemicals have been working, but the Varroa mites are becoming increasingly more resistant to them, so we need to find a new treatment. So that's why I figured maybe fungi could be used as a natural treatment against Varroa mites by working as either an attractant or a repellent. And so if it was an attractant to Varroa mites, we could put the fungi, specifically a spore solution, into traps which can lure the Varroa mites in and then trap them. And then if it was a repellent, we can put the spore solution into the hive, which would drive the Varroa mites out. So the first thing I had to do for my project was I had to go around the parks and such and collect different types of fungi. And once I had those fungi, I cultured them onto petri dishes and to grow them, and then I made spore suspensions from those petri dishes. And the way I made the spore suspensions was I took 14 milliliters of 0.1% tween 20 solution. I poured that over the cultured petri dish, swirled it around a little, and then poured the solution over a cheesecloth, which is just like a mesh cloth. That way it would separate the spores from the mycelium. And these are actually some of the cultures I made spore suspensions on. And mycelium are they're spores that became the roots of the fungi. And that is how the fungi gets its nutrients. So you can actually see in this plate specifically very well the lines, that's the mycelium right there. And then once I had the spore suspensions made, I diluted the spores solution to 7 million spores per milliliter. And the way I figured out how many spores there were was by using a hemocytometer, which is this thing right here. And that just helps make counting the spores a lot easier and quicker. And then along with the fungi spore solutions, I made a positive control, which I'm going to make a second one, but I don't know what yet. But the first one I made is a solution of 1 parts per million of cinnamon oil, which is a known repellent to Varroa mites. And that was put in 0.1% tween 20 solution also. So once I had all the spore suspensions made, I could start my trials. So I prepared my trials by first collecting Varroa mites via sugar shake, which there's a picture of some bees I did a sugar shake on. It's kind of hard to see with my video picture. And then once I got them off the bees, which is I separated them into this petri dish that has a wet filter paper on the bottom to keep them humid while I prepare the rest of the things I need to do before I can start the trials. And so then once I did that, in sterile petri dishes, I would put one bee on one side and another bee on the other side, which are dead. And then one bee was inoculated with the negative control, which is 0.1% tween 20, since that's what all the solutions I made were made in. And then the other bee was inoculated with a positive control or one of the fungi. And then finally I could start the trials, and so I put the petri dish into a desiccator, which is just like a container that keeps the humidity in, which the humidity was 75% for my project. And then I placed the desiccator into a climate cabinet to keep the air at 35 degrees Celsius. And so each trial lasted 3 hours, and during those 3 hours, the Varroa mites activity was checked at 10-minute intervals for the first hour, and then 30-minute intervals for the second and third hour. And during each of those intervals, I would categorize the mites activity as either they climbed on a fungus treated or control bee, the Varroa mite was closer to a given bee, the mite was undecided, which means they were about equal distance between the bees. And then I also additionally, for each of those observations, said if the Varroa mite was moving or stationary at that time of the observation. And so I still need to do more trials. I haven't done too many since I had some issues with humidity at first and had to redo some trials. But I want to do at least 10 trials for 2 positive controls and then at least 3 fungi. And so if any of those fungi show potential to be an attractant or repellent, then I will do PCR on them, which means polymerase chain reaction. And PCR is where you take genetic material, such as DNA, from an organism, and you put it into this machine, and it compares it to this large database of known organisms. And then that allows you to determine what organism the fungi or whatever it is. And so also, if any of the fungi are potential attractants or repellents, my next test will be to see the fungi's effect on live bees, to see if it's safe for the bees. And then if that goes well, then I will check the fungi's effect on the whole hive. So that's my project. Thank you all for listening. If you guys have any questions, I included my email on this slide if you wish to reach out to me. And I hope you all have a beautiful day. Thank you.